Hey y'all, what's up? So we're going to do a three variable system. I have one example and one kind of fringe case. So, so let's go ahead and get right to it. All right. So here's my example. If you want to go ahead and pause the video and write this down so you can follow along, that'd be sick. This is the solution. So we'll see if I'm right or not, right? All right. So how we do this is we're going to eliminate the same variable twice. So what does that look like? Well, I'm going to eliminate x from the first two, and then from equation 2 and 3, I'm going to also eliminate x. And let's see what happens when I do that. So I'm going to multiply the second one by 2. So the first one will stay the same. The second one, I'll have negative 2x plus 2y plus 10z is equal to 24. And I add this together, I get y plus 11z is equal to 32. Now I'm going to add the equation 2 and 3, so I get 0x, so I get 7y plus 6z is equal to 11. All right, so now what I'm going to do is I have a 2 by 2 system now. So I have just a system with y and z. So I'm going to eliminate y. So I'm going to multiply this one by negative 7. So I'll have negative 7y minus 77z is equal to, that'll be 224, negative 224. Now I can add this and I get negative 71z is equal to negative 213. Divide by negative 71, and I get z is equal to 3. So as you can see, this is going to be x, y, and z. So z is indeed 3. And now what I'm going to do here is I'm going to go ahead and back substitute this into one of my previous equations so I can solve for y. So I'm going to have y plus 11 times 3 is equal to 32. So y plus 33 is equal to 32, and I get y is equal to negative 1. So y is indeed negative 1. Now I have z and y, so I'm going to use both of these, and I'm going to substitute it into this equation. Or it can be any one of these three. I'm just going to use this third one, for example. And I get x plus 6 times negative 1 plus 3 is equal to negative 1. I get x, so this is minus 6 plus 3, so that's minus 3 equals minus 1. Add 3 to both sides, and you get x is equal to 2. So x is 2, y is negative 1, z is 3. You box your answer, and that's it. So you're going to want to answer as an ordered triplet because it's not an ordered pair, because an ordered pair, pair is 2. It's an ordered triplet because there's 3 numbers now. Now you might be like, Mr. Lee, what is a special case? Well, you should be familiar with the two variable systems. If you get 0 equals 0, that's infinitely many solutions. If you get something like 0 equals 5 or something weird like that, that's no solution. So it's pretty similar to here. If you ever, for the most part, if you ever end up with 0 equals 0, you're most likely going to have infinitely many solutions, except in this case. So I'm going to show you this case here. So I'm going to multiply the second one by this first, I'm going to multiply this first one by negative 2. So I'll have negative 2x minus 2y minus 2z is equal to negative 10, and I'm going to add it to the second one. So 2x plus 2y plus 2z equals 10. And I get 0, 0, 0, so I get 0 over here, and then negative 10 plus 10, that's 0. So I get 0 equals 0. And you might be like, oh my gosh, I got 0 equals 0, so that means it has to be infinitely many solutions. Well, that's not necessarily the case. If you, what you need to do if you get exactly this is you need to test if this other one, so this other set, so number 2 and number 3, or maybe number 1 and number 3, you need to make sure that that is also 0 over 0, 0 equals 0. Basically, it's infinitely many solutions only here if all 3 of these equations are the same. So let's check it out. So I'm going to add the first one and the third one. So x minus x, that's 0. Y minus y, that's 0. Z minus z, that's 0. So I get 0 equals 8. So this is no solution, okay? If you get something with no solution, like 0 equals 8, and infinitely many solutions, like 0 equals 0, the no solution trumps the infinitely many, okay? No solution trumps infinitely many solutions every time. The reason why this one in particular is no solution is because basically this is 3 parallel planes. So it will look something like this. So it's 2 parallel planes, but this first one is going to be equations 1 and 2. And this second one over here is going to be, this is equation number 3. So that's why equation 1 and 2, when we combined them, we got 0 equals 0, because for those two, they're the same thing, so it's infinitely many. But for equation 3, it's actually parallel to it, so it doesn't intersect it at all. So that's why it's no solution. Okay, because it's no solution with all 3 of them. All right, that's gonna be it for the video. I know that the special cases for this can get kind of crazy, but it's okay. I believe in you. So that's gonna be it. See ya.